question. So bag A contains 2 red and 3 green balls. And 2 bars are chosen without replacement. That's a key word. Without replacement means they don't go back. So I can pick a ball, it could be red, or I could pick a ball, it could be green. And I know if I pick the red ball, it's going to be 2/5, because it's 2 out of 5. When I do it again, I don't replace it. So now to get a red one, I have a 1/4, and this is a 3/4. And I can work the same here. This is 3/5, and so on. I want to find the probability of 2 red balls. That means I want to have a probability of a red and a red, which is this branch. So it's 2/5 times 1/4, which will be 1/10 if I do that, or 0.1. Now, similar to this one, I got 4 red and 6 green, but it's with replacement. It means they go back into the bag. So I could pull a red, and that's a 4/6, or, sorry, it's not 4/6, it's 4 to 10. 4 to 10. Or 6 out of 10 is green. Well, I'm just going for the red ball, so I know I can go again for a red, and that is again 4 out of 10 because I put it back in, and this is going to be 6 out of 10 for green. And again, I'm only looking for the probability of a red and a red, which will be 4/10 times 4/10, which, if I do that, ends up being 4 to 25, which is 0.16. Okay, these two are fairly straightforward. Now, I have a standard die with 6 faces are rolled. If a 1 or 6 is obtained, then I choose 2 balls from bag A without replacement. So basically, this problem here is set up for part C. And similarly, 2 balls are chosen from bag B with replacement. This is going to be part B. So it's connected here. So I roll a die. I get a 1 or 6, and that happens, I know, 2 out of 6 times. Or I get 4 to 6 times, I get a 2, 3, 4, or 5. That's the other possibility. And so if I get a 1 or a 6, I then am going to be in bag A. And I could get 2 red balls, or I could not get 2 red balls when I go to bag A. I've already calculated this probability to be 10% chance of getting 2 red balls. This is 0.1. Because I could make a tree here, but it's going to end up being this scenario, and this is 0.9. Similarly, if I roll a 2, 3, or a 5, I go to bag B, and I could get 2 red balls here, or not 2 red balls. The probability of 2 red balls, I know, is 0.16. So this is 0.16, or this is 0.84. And so if I'm looking for the probability of now 2 red balls, well, that's going to be the 2/6, or which is 1/3. So I'll replace this with a 1/3 and this with a 2/3. So I'm going to get 1/3 times 0.1, which is this branch, plus I could do this branch here, which is going to be 2/3 times 0.16, which works out to a 0.14. Okay, and so I use a new tree diagram and the previous probabilities to solve this scenario. So now it says, given that 2 balls are chosen. Okay, and so when I think about this scenario here, given that 2 balls are chosen, given implies going to be conditional. Conditional. Find the probability. So ultimately, I'm trying to find the probability that a 1 or 6 obtains. So I'm finding the probability of a 1 or 6. That's the probability I'm given. And I look for this phrase here, find the probability of this. That's how I know what to put first, given that there are 2 red balls. Well, using the definition of conditional probability says the probability of a 1 or 6 and 2 red balls over the probability of 2 red balls. Well, if I look above here, this is the probability of 2 red balls. So I know the bottom of my fraction is 0.14. Well, the top of the fraction says 1 or 6 and a red ball. That's this top of the tree diagram. So the 1/3 times 0.1. This is 1/3 times 0.1. And when I do that in my calculator, I know I end up with 0.239. So use the definition, think about what these values are, and plug the values in.